An ordinary differential equation, ODE, is an equation that involves one or more derivatives of an unknown function of a single variable. The order of an ODE is the highest order derivative that appears in the equation. A first-order ODE can be written in the form yx equals fx, yx, where yx is the unknown function, yx is its derivative, and fx, y, is a given function. A second-order ODE can be written in the form yx equals fx, yx, yx, where yx is the unknown function, yx, and yx are its first and second derivatives, and fx, y, z, is a given function. A homogeneous ODE is one in which the right-hand side is 0, i.e., fx, y, equals 0, for a first-order ODE, or fx, y, z, equals 0, for a second-order ODE. A non-homogeneous ODE is one in which the right-hand side is not 0. The general solution of an ODE is a family of functions that satisfies the equation. The particular solution of an ODE is a specific function that satisfies the equation, subject to given initial or boundary conditions. An initial value problem, I, is an ODE with initial conditions specified at a single point. A boundary value problem, BVP, is an ODE with conditions specified at multiple points. The existence and uniqueness theorem states that for a first-order ODE yx equals fx, yx, with initial condition yx0 equals y0. There exists a unique solution in some interval around x0 if fx, y, and f/y are continuous in a rectangle around x0, y0. The method of separation of variables is a technique for solving certain types of first-order ODEs by separating the variables on either side of the equation. The method of integrating factors is a technique for solving certain types of first-order ODEs by multiplying both sides of the equation by a suitable integrating factor. The method of undetermined coefficients is a technique for finding the particular solution of a non-homogeneous second-order ODE by assuming a particular form for the solution. The method of variation of parameters is a technique for finding the particular solution of a non-homogeneous second-order ODE by assuming a linear combination of the solutions to the homogeneous equation. The Runge-Kutta method is a numerical technique for approximating the solution of an ODE by using a weighted average of the function values at several points within each interval. The Euler method is a simple numerical technique for approximating the solution of a first-order ODE by using a finite difference approximation of the derivative. A system of first-order ODEs can be written in the form yt E equals fyt, t, where yt is a vector-valued function and f is a vector-valued function. Such a system can be solved numerically using methods such as the Euler method or the Runge-Kutta method. A phase portrait is a graphical representation of the solutions to a system of first-order ODEs, showing the behavior of the solutions as time evolves. A fixed point, or equilibrium point, of a system of first-order ODEs is a solution where the derivative is 0, i.e., fyt equals 0. At a fixed point, the solution is constant over time. A linear system of first-order ODEs can be written in the form yt equals at, where yt is a vector-valued function and a is a constant matrix. The solution to such a system can be found using the matrix exponential. The characteristic equation of a linear second-order ODE with constant coefficients can be found by substituting y equals ERT into the equation and solving for r. The general solution is then a linear combination of ERT and EST, where r and s are the roots of the characteristic equation. The Wronskian is a determinant that can be used to determine if a set of solutions to a linear second-order ODE with constant coefficients is linearly independent. The Laplace transform is a mathematical tool for transforming a function of time into a function of a complex variable s. It can be used to solve certain types of linear odes with constant coefficients. The Fourier transform is a mathematical tool for transforming a function of time into a function of frequency. It can be used to solve certain types of linear odes with variable coefficients. Sturm-Liouville theory is a branch of mathematical analysis that deals with a special class of second-order linear odes with variable coefficients, known as Sturm-Liouville equations. These equations arise in a wide range of applications, such as quantum mechanics, heat transfer, and fluid dynamics. The method of characteristics is a technique for solving certain types of first-order partial differential equations by reducing them to systems of first-order odes. The method of characteristics can also be used to study the properties of solutions to hyperbolics, such as the wave equation and the advection equation. The method of characteristics can be extended to second orders, such as the heat equation and the Laplace equation. By introducing auxiliary variables and reducing the equation to a system of first-order equations. The theory of dynamical systems is a branch of mathematics that deals with the qualitative behavior of solutions to differential equations. It studies the long-term behavior of solutions, such as stability, periodicity, and chaos. Chaos theory is a subfield of dynamical systems theory that studies the behavior of systems that are highly sensitive to initial conditions, known as chaotic systems. Chaotic systems can exhibit seemingly random behavior even though they are governed by deterministic equations. The concept of bifurcation theory is important in the study of dynamical systems. A bifurcation occurs when a small change in a parameter of the system causes a qualitative change in the behavior of the solutions, such as the appearance of a new steady state or periodic orbit. Nonlinear odes are often difficult to solve analytically, and numerical methods are often used to approximate their solutions. These methods include finite difference methods, finite element methods, and spectral methods. The study of odes is an active area of research, and there are many open problems and unsolved questions in the field. Some of these include the existence and uniqueness of solutions to certain types of equations, the regularity of solutions, and the long-term behavior of solutions.